Question 21b. Use Nick's method to work out an estimate of the distance. I've copied the graph from the previous question onto this page just so we can see it all together. To work out the area of a triangle, we multiply base times height and then half it. Using the values on our axes, we can see that this is 140 seconds across. And we know from the coordinates we were given, this top point here is should be about 9.8. If we multiply this by a half, what we end up with is his estimate of the area of the triangle. Which is 686. So Nick estimates that the area travelled is 686 metres. For question 21c, Helen uses a different method. She starts by estimating how many of the smallest squares are in the region between the graph and the horizontal axes. Her estimate is 1,550 squares. Complete Helen's method to estimate the distance. In trying to find distance using a speed-time graph, we can multiply speed by time, which would be the area under the graph. But what she's assumed then is that every square at this stage would equal 1 second and 1 metre, and we know that's not the case. So if we find out what the value of each square is, we can divide her estimate by that value to find out what the distance should be, using the scale on the graph. Going up in time, every small square, well, there's 5 squares to equal 1 second, so each square is going to be 0.2 seconds. We multiply that by the distance of each square. Well, if there's 5 squares being 10 seconds, that's 2 seconds per square. Which means that every square that she's calculated is actually going to be 0.4 meters per second times seconds, meters. So if we find out what proportion that is of her total value, 1,550 multiplied by 0.4, we'll find out what her estimate would be. 1,550 multiplied by 0.4 gives an estimate of 620 meters. This answer is very close to Nick's, so it's a reasonable estimate using both methods.